All right, and back here on lesson 3.2 and 3.3, where we are going to take a look at two-way tables and Venn diagrams. So we were collecting data. You can do this in your class. I just created some data here saying that if people can or cannot do these two facial expression emojis. So I filled in the two-way table down here. So if they can do both the taco tongue and the evil eyebrow, we said that there's 8 people who can. Yes, taco tongue, no evil eyebrow. 5, no taco tongue, yes, evil eyebrow, there's 10 people. And then no taco tongue, yes, evil eyebrow, there's 7. So the two-way table we can extend out and just show and just add kind of a cross here with yes, taco tongue, regardless if they can do the evil eyebrow or not. We have 8 and 5 for a total of 13. People who cannot do taco tongue, whether they can do the evil eyebrow or not, that will be 10 and 7, which is 17. We can add down as well, yes, evil eyebrow, and yes, regardless if they can do taco tongue or not, is 8 and 10 is 18. And then we can add down for if people who cannot do evil eyebrow. And then when we add to the right 18 and 12 or 13 and 17 down, both of those get us 30 total people in the class. So these 4 numbers we are going to also put into our Venn diagram over here on the right. So I like to start with on the top of our Venn diagram our total. So I have 30 total students in this made-up class. And then I like to start in the middle as well. So in the middle here, this left circle, this whole left circle is going to be people who can do the taco tongue. The whole right circle is going to be people who can do the evil eyebrow. So the overlap in the middle here is going to be people who can do both. So the people who can do both, there are 8 people who can do both. So there are 8 people who can do both. Now, the left side of that circle are people who can do the taco tongue, but no evil eyebrow. Why is it no evil eyebrow? Because it's outside of the circle where people can do the evil eyebrow. So people who can do the taco tongue and cannot do the evil eyebrow, yes, taco tongue, no evil eyebrow, looks like that's 5. So then the right side of the evil eyebrow circle are people who can do the evil eyebrow, but let me move my space here. 3, 2, 1. To the right side of that evil eyebrow circle, people can do the evil eyebrow, but cannot do the taco tongue because it's outside of the taco tongue circle. So yes, evil eyebrow, no taco tongue, looks like 10 people fit that criteria. And then there's a blank space out here. You don't see it often in Venn diagrams in the wild. However, in math, we also have to account for people who don't fit in either of the circles. So people who can't do taco tongue in that left circle, people who can't do the evil eyebrow in the circle on the right, they both combine and fit out here. This looks like a nice hot dog now. They are people who can't do either, and there looks to be 7 of those people who cannot do either evil eyebrow nor taco tongue. Give you a second to fill that out and kind of see where those all match up. Kind of erase some stuff there. So with a Venn diagram, all we need to do is label the left and right circle, what they are, and we can infer that in the middle we have the overlap where they both exist. On the left, where the left circle is true and the right circle is not true. On the right of that overlap circles there, where the right circle is true, but the left circle is false. And then outside is where both circles are not true, the people that can't fit in either of those circles. All right, so let us answer number 2 together. And then we're going to answer some and questions, some overlapping questions there. So yes, taco tongue. How many people total said yes to taco tongue? That was 13 out of my total of 30. No taco tongue. That is 17 out of total of 30. Notice that these add to all 30 out of 30. That's important. On the right side there, yes, evil eyebrow is going to be yes, evil eyebrow. That's 18 out of 30. And then no evil eyebrow is going to be that 12 out of 30. And then we get into our overlaps here. That's going to be inside either the Venn diagram or inside the box that's in our two-way Venn diagram table. So yes, taco tongue, and yes, evil eyebrow. So that's going to be our 8 out of 30. Yes, taco tongue, and no evil eyebrow. That's going to be our 5 out of 30. Yes, evil eyebrow, no taco tongue. That's going to be our 10 out of 30. And then no and no is going to be our 7 out of 30. All right. So again, down here, 3 is going to start with these two repeated. So yes, evil eyebrow, 18 out of 30. No evil eyebrow, 12 out of 30. All right, so yes, evil eyebrow, no evil eyebrow. We can call this a complement, or we can also call them mutually exclusive. So because of that, then they are complements. When we add them, when we have them and say yes, evil eyebrow, or no evil eyebrow, that should cover everything. So that'll be the probability of one of them plus the probability of the other, if we're calling this A, and the other B. When we add them together, should be everything. And you know, it's there's no overlap there. It's either one or the other. You can't be both. Versus if we go down to number 4, when we say yes, taco tongue. So we look at taco tongue, and that's 13 out of 30. Probability of choosing someone that can do the evil eyebrow, that's 18 out of 30. If we try that same thing here and we say they're mutually exclusive, we can just add them together. What happens, we end up getting 13 and 18 is 31 out of 30. Can you have 31 out of 30, 31 students out of 30? You can't. That's over 100% in probability. We can't have over 100%. So instead, what we have to do is we have to take that over. We have to figure out what the overlap is there and subtract it. So what we're going to have to do is we're going to figure out what went wrong, what made it go over 100%. So let's take a look at that 13. So that 13 is going to come from the yes taco tongue. That's that 5 and the 8. And then we're going to look and see where we got that 18. That 18 is the yes evil eyebrow on the right side there. That's the 10 and the 8. So what you may notice is that we're counting the 5, the 10, and the 8, we're counting twice. So because we're counting that 8 twice, we don't want to count it twice. We got to subtract that 8 out. So what we'll do is we'll say the yes taco tongue, the yes evil eyebrow, 13 and the 18, and we'll take away the 8 out of 30. So when we do that, we end up with 13 plus 18, that's 31. Take away 8, 13 plus 18 minus 8 over 30. So that's going to give us 31 minus 8 is 23 out of 30. So 23 people out of the total of 30 can either say yes taco tongue, yes evil eyebrow, or both. So where we had in number 3, we had mutually exclusive events. We say the probability of A or B was just adding the probability of A plus the probability of B. Here we don't have mutually exclusive events. Because there's that overlap. There are some people that say, yes, I can do the taco tongue and the evil eyebrow. There's that overlap there. They're not completely separate from each other. So we can't use that addition rule that we just did. We have to addend it and add this like subtraction part to it. So the probability of A or B is now going to become the probability of A plus the probability of B, and we'll subtract the probability of both. And then that's going to be called our general addition rule. So on to the next page, where we're going to sum up what we've been doing with our important ideas from this lesson. And our first one is going to be the two-way frequency table. And so we can kind of sketch our frequency table here. We can draw a shape. We can totally do that. We got our little frequency table there. We got two vertical lines. And then our events, we're going to say are A and then the complement of A. B and the complement of B, which will be a smaller b, smaller c, and the complement. So remember, AC is the complement of A. So if A is having blue eyes, then the complement of A is not having blue eyes. So we're going to put some numbers in there. I'm just going to number 1, 2, 3, 4, but I'm going to color code it so you can see where it goes. So we'll say that the red is 1, whatever this color is 2. We can say that this color is 3, and then this color is 4. And we're going to draw our Venn diagram. So we're going to get our shape tool out. We're going to draw a rectangle. So we have our rectangle. We're going to insert some circles. Move that circle slightly. Ooh, that's fun. There we go. That's how you make a circle. Right in the middle. Let's copy it. That's not what I wanted to do. Now I have a random thing there. I'm going to cut all this out. It's going to be awesome. Just drawing circles. All right, 3, 2, 1. Now that we've expertly jumped ahead and drawn our circles, we're going to fill in where these numbers go. So I recommend starting in the middle where both things are true, and that's going to be this red number 1. And then we can say, oh, we definitely have to label these, don't we? So let's label them in black. So we can say that that's not black. We can say that this left circle is A, the right circle is B, and then outside the circles are the complement. So let's say our pink is going to be A is true and B is the complement. So 4 is going to go there. Let's look at what's another color we had. I think this was a color we had. That seems to be 2, where B is true, but it's the complement of A. So let's hope it goes there and those colors match to you. I am colorblind, by the way. And then 3 is going to be where both are not true, the opposite of A, the opposite of B, and that's going to be outside of both of those. So a little bit of room left to jot down some notes about the addition rule, but this is our Venn diagram. And now we're going to talk about the general addition rule. And our general addition rule is going to be that, who knows what color we're going to have? There we go. A or B is going to be the probability of A plus the probability of B minus the probability of A and B. And then that is for non-mutually exclusive events if we have mutually exclusive events, then what that means is that the probability of A and B happening is 0. That's what mutually exclusive events means. There can be no overlap between the two. So then our formula, let's just write it in a slightly different color, is going to be probability of A or B is just going to equal the probability of A plus the probability of B. There you have it, two-way frequency table and Venn diagram. You should check your understanding down below. We got some more additional rule practice. You got some more additional stuff there as well. And then your teacher will probably throw up a math Excel for you as well. As always, ask your teacher questions, and we'll see you next time.